And her title of the talk is Cybersecurity in Complex Systems, Facilitating Secure and Efficient Applications. Susanne, you're on.
Okay, thanks. Can you hear me and can you see the slides?
Yep.
Okay, fantastic. Okay, so thank you very much for the opportunity. As the other said, it's really super exciting, and hopefully we'll have new collaborations coming out of this. So I think with all the discussions we already had in the previous talks, it actually nicely connects in a multiple fashion, so to say. I termed it, cybersecurity in complex systems. And I'll talk about some of the projects really under the context of, well, enabling applications that we want to use, want to do, but figuring out ways to making them more secure or specifically more private, while trying to maintain as much as possible from the original features that we like, love, and would like to maintain. So it's kind of a yin-yang in many kind of ways that we're looking at. And I'll talk a little bit about those kinds of compromises as we go through the slides. So the first one that I want to talk about is really the facilitating of all sorts of applications in making them more privacy preserving. And for the sake of this talk, I'm going to focus mostly on one application, namely bartering. And I'm sure that we've all kind of, engaged in some form of bartering sometime in our lives. It's considered one of the earliest forms of trading, going back to the beginning of humanity, and what we're seeing in this kind of a sharing economy is that we have a renewed interest in this kind of method in dealing with the fact that many of us, most of us, have lots of things sitting around that we don't need or want anymore, but we would like for them to be used and be of use by someone else. And in return, maybe we can obtain something that we have an interest in. So this is on the private side, but even on the business side, there is an increased interest, a renewed interest in bartering, and it actually makes up a substantial amount of the marketplace. And one interesting development that we've seen with cyberspace is that there is an increasing number of online platforms that are facilitating all sorts of bartering markets, so to say, whether this is for books or general commodities, or more in a localized fashion, kind of getting help, having help in a household environment, in your garden, whatever. So there's different ways of looking at that. And the interesting thing is that kind of with these online platforms, we've already kind of tackled one of the bigger challenges when it comes to bartering, because in order to enable bartering, the trade partners have to be in the same place at the same time in order to haggle over what the trade is going to be like. Now with online platforms, we've eliminated this time space element, but at the same time, it opens up for a number of additional problems that we're trying to tackle with our work. And that's really kind of the privacy and also kind of sometimes coined as unbiasedness, fairness, the room for negotiation. So when we sign up for these platforms, we have to provide all sorts of information, whether that's personal information, but at the very least, we somehow have to announce what we're interested in and what we're looking for. So we have to kind of really make this known, which can then be mined and used in other contexts, can be used against us if we have to indicate, say, how many apples for how many pears we would like to have. It definitely kind of limits the room for negotiation. And this is where our work comes in, where we're trying to enable this kind of privacy preserving type bartering, where you can keep your offers and demands, your intentions private to yourself. We enable the encryption of this information. And then our protocols actually allow for the figuring out of who can trade with who, who will exchange what commodity with whom at what exchange rate, at what price, so to say. We can do all of that based on the encrypted data, and in the end, only those trade partners who actually will engage in trading, meaning they will receive some commodity from some other entity or will give whatever they have to offer to someone else. This is what they learn, meaning they only learn their immediate trade partners. They don't learn the full structure, which is indicated, for example, here in these orange or reddish type errors, depending on how it displays on your side. But it's really just, if you're the individual, the outgoing and the incoming error that you will learn, and you will learn what you receive, what you send off, and at what rate. And so we're really limiting the kind of information that will be known to others in the system to the absolute bare minimum in order to carry out this kind of an application, namely making bartering privacy preserving. And so this is kind of just an example of the types of applications we're looking at, that we have a day-to-day application, and we're trying to use secure multi-party computation, which, you know, from a 50,000-mile view is that we're enabling specific operations on encrypted data in a very sophisticated fashion, so that we can then also have succinct arguments over the security, which means in this case, the privacy guarantees that we can accomplish, plus the correctness of the computation that we're trying to facilitate with these kinds of sophisticated operations. So in kind of a general type fashion, we achieve that we have a certain level of privacy, and we achieve that your preferences, meaning what you intend and what you want to gain, is really recognized in the proper fashion, and we can show and prove that. So currently we're working on taking this from a static view, from executing a protocol with a fixed set of entities and a fixed set of quotes, to really a system perspective, to making it even closer to what we want to see in practice. And that's where this trade-off comes in that I talked about before, namely, we have to really kind of tease out the specifics of the privacy guarantees that we can have, because now we have entering and leaving entities, and we have possibility of looking at this multiple times, participating multiple times. And then the question is, what does that do in terms of the privacy guarantees that I talked about before in just a very static kind of a setting? And at the same time, you know, how do we solve all sorts of kind of practical issues, how we enroll in the system in an anonymous fashion and whatnot. So this is what we're working on right now with a colleague at RWTH Aachen. And this is funded by NSF and the DFG. Very quickly, because time has advanced, I talked a little too much about this. A second kind of a system-y type of a look and project is to look at system and security economics, where we're trying to offset productivity versus privacy. And I just depicted two kind of complex systems. On the left side, it's in the health environment. If you look from the perspective of a hospital and they want to facilitate the treatment of patients, who they have to share data with and what that actually means in terms of exchanging that, having some of the entities obviously being more involved. And then the question arises, how much information can they actually extract on top of the individual information flows, because they're on a number of critical paths. They can actually aggregate information that they receive. And what does that do in terms of unintended information disclosures? On the right side, it's for the maritime transportation system, even more complex, even more convoluted. And so we're really looking at how much privacy can we maintain, be this through mechanisms, protocols, as I described an example before, be it through regulations, for example, HIPAA regulation, be it laws or whatnot. And at the same time, what does that mean in terms of productivity in the system? How easily can I carry out the tasks that I have to carry out, being one of the specific entities here? And what's the incentive for these entities to actually try and circumvent those measures put in place? And what does that then again mean in terms of the privacy and the overall security of the system? Lastly, I want to just briefly mention that I feel very passionate about the fact that it's not just research in terms of research projects in pushing them forward, but how we also connect this into education, and in particular, the many cybersecurity programs that we have at Stevens. We really need to teach our students, on one side, the advances on the research side, and at the same time, we also have to advance cybersecurity education in and by its own. So some of the projects we're working in this context is how we can effectively introduce the research experience into the curriculum, even say for undergraduate students, through real world research projects, for example, that are offered from government agencies, and can get the students to really experience what it means to do research, how you fail, how you succeed, how you make advances, and that a negative result is also a result that's very important. And kind of mimicking this ever-advancing field of cybersecurity, the ever-advancing questions, and what I knew yesterday isn't sufficient today to secure the system for tomorrow. An orthogonal line to this is how we best prepare our students once they graduate. We want them to really be able to have an education that really carries a lifelong career. At the same time, we have to recognize that they have to execute a job, and on the job, they're expected to perform ideally on day one. And so how do we actually bridge this kind of a gap, and how do we kind of match this in the best possible fashion so that both on the academic side with the programs and also on the expectation side from an employer, we know what we're getting into. And that's really kind of leading us into the context of competency-based assessment versus outcomes-based assessment. And then last but not least, an area on cybersecurity ethics. And I'll stop here and just take questions. Thank you.
Great, thanks, Susanne, particularly for emphasizing the importance of bridging research with education, right? And particularly for workforce training in this critically important cybersecurity domain. One question I have is that how would you envision the internet commerce to benefit from your privacy preservation applications, the concepts, and potentially software and tools development?
Yeah, so I mean, I envisioned that the desire for privacy is something that will increase again over time, so that the general public is really asking for privacy guarantees to be present. And so with our work, we will be able to really have some succinct statement as to what kind of privacy guarantees we can achieve, which in an ideal world would definitely give us a market advantage. One thing that I didn't mention, but something that we're working on, is to really take this bartering application into the context of organ donation. And so, for example, in that context, you have the problem that there is great suspicion that the matching of a donor with the person who will receive the donation may not be done in the right way, that there might be some fiddling, that there might be, some taking advantage by certain entities. And by introducing these mechanisms in a privacy preserving fashion, where we can make a statement on one side on the privacy, really protecting the privacy of the patient, and also the unbiasedness guarantees that everybody has the same chance of receiving this donation, assuming that the matching of the criteria, in this case, it's really kind of, the blood type and whatnot, is at the same level, that this will hopefully lead to a greater acceptance of registering, for example, as a living donor for kidney donations, and will really help us as a society to move forward and really, address a societal need in a very different fashion. So I'm hoping for that, and that's what we're striving for.
Well, thanks very much for bringing in also about this important extension to the healthcare arena as well.